This textbook jumps in and never ever solves or never ever covers solving for x. They introduce a lesson where you are converting word sentences to mathematical equations and solving them, having never gone over how to solve for x. And it should be a review. Pre-algebra should have covered that for you, and if you've been at PCAL, you have covered it. But before we continue in our textbooks, we are going to do a couple of review lessons of solving for x. It's absolutely crucial. Negatives and positives, order of operations, and solving for x are crucial from your math from here on out. So we're not going to use our textbooks pretty much at all this week. I think I'm actually looking right now to see our list, but I don't think we're going to even need we will on our third lesson, we'll need our textbook. So we're going to do a quick review here of solving for x, and then you have an online assignment like we discussed in our face-to-face time. So let's start walking through. Part of this is going to be super simple, but hopefully, if it's not, no big deal. You can figure it out. We'll go slow and go from there. Two x plus 4. So the first thing I need to remember is two things side by side without a sign means multiply. At this level, we're not going to use an x for multiplication. And in problems like this, when I'm dealing with a single term, I rarely am going to see it written like this. Now, when I'm simplifying things, I might see parentheses, but Algebra 1 level, Algebra 2 level, and beyond, they just write them side by side. And we know two things side by side with no sign means multiply. And my goal is to solve for this. Now, some of us can look at this and say, well, 2 times 7 is 14. But let me show you how we're going to mathematically work this problem step by step and get there. And while it's not important necessarily right now, if we can start with these simple ones, understanding the process, when they get bigger, it'll make a little bit more sense. If our goal is to get x by itself, I've got to get rid of this. And I've got to get rid of it by moving it over here. And when I move it, the operation changes. Well, what's the mathematical operation? It's multiplication in this one. So when I pick the 2 up and I move it over the equal sign, The operation changes from multiplication to division. I'm not touching the x. I'm not touching the equals. I'm not touching the 14, but I am moving the 2 from the left side to the right side. When I do that, the operation changes. It goes from multiplication to division, and then 14 divided by 2 is 7. Again, I know you can look at that and do it, but that's how it's worked out mathematically. Now, let's look at this problem. My goal is still to get x by itself. My goal is still to have x equals. So I have to move everything away from the x. I have a 2 and I have a 4. And the rule is save the x for last. Whatever is touching the x, move that last. Move everything else first. Okay? So I'm going to need to pick up my plus 4, and I'm going to need to move it over the equal sign over here. When I do that, the operation changes from plus 4 to minus 4. I'm not touching the 2x. I'm not touching the equals. I'm not touching the 14. I'm picking my plus 4 up. I'm moving it over the equal sign, so the operation changes from addition to subtraction. Well, what is 14 minus 4? 14 minus 4 is 10. Now I need to move my 2. What operation is happening? Two things side by side with no sign is multiply. So when I move that over, it becomes divided by 2 because the operation changes, and therefore x equals 5. Now, if I wanted to take the time to check this, what if I can fit this up here small? I could plug this 5 back in here and do 2 times 5 plus 4, which is 10 plus 4, which is 14, which is what I wanted. I'm not going to require you to check it. I mean, if you're taking a test and want to see if it's right, you can always check it that way. All right, let's take this another step. Let's take this another step and look at this problem. Now, don't start freaking out because there's more than one x. What we need to do is we need to get our x's together. And for whatever reason, our brains process x equals something better than something equals x. We just like to have x on the left side. So what we're going to do is we're going to get all of our x's on one side of the equal sign. Typically, we want them on the left side because our brains just think better that way. So I'm going to move my minus 3x. That minus has to stay with it, okay? I'm going to move it over my equal sign. When I do that, the sign or the operation changes. I'm not touching my 2x. I'm not touching my 4. Now my minus 3x is going to move from one side to the other and become plus 3x because the operation changes. Now I need to move my plus 4, my non-variable term, my term with no x's, over to the other guy who has no x's, okay? I'm not touching my 2x. I'm not touching my 3x. I'm not touching my equals 14, but I'm going to move plus 4 over the equal sign. When I do that, the operation changes, so it becomes minus 4. Now I'm going to simplify. 2x plus 3x is 7x. I have 2 x's. What in the world, 7x? 5x. I have 2 x's. I get 3 more x's. Now I have 5x. 14 minus 4 is 10. All right, I'm not done yet because x is not by itself. Remember, that's my whole goal. And kids say that to me a lot. How do I know when I'm done? You're done when x is by itself. So now I need to get this 5 over here away from my x. And remember, the operation changes. So what operation is happening here? Well, two things side by side with no sign means multiply. So I'm going to move that 5 over, and the operation is going to change from multiplication to division, and 10 divided by 5 is 2, so x equals 2. kind of the same idea in that I have two x's. So I'm going to go ahead and combine those. If I have 9x's and I get 2 more x's, I now have 11x. Now that's a negative 29, okay? You have to also remember your negative and positive rules. I need to get x by itself, so I'm going to move this plus 7 over. When I move a plus 7 over, it becomes a minus. All right, now listen, you're going to have to remember your negative and positive rules. These are both negative, so what I'm technically going to do is I'm going to add. Ooh, I don't know what that is. I'm going to add, and when I add 29 plus 7, I get 36, and they're both negative. So the answer is negative. All right, I'm not done yet. I got to move this 11 over. When I move it over, it's going to become division. Now, this is important. At this level of mathematics, this can't be reduced. That is your answer. Do not convert it to a decimal. Your answers need to stay in fraction form. And the reason is, if I do 36 divided by 11, I end up with a never-ending decimal. It repeats forever and forever and forever, and that's not workable. At some point later on in your mathematical career, you're going to need to use this information on other problems and other pieces and other steps of a problem. When I type it in my calculator, I get 3.27 for all of eternity. I can't plug that in to use it. A fraction is tangible. Decimals, repeating decimals, never-ending decimals are not. So leave your fraction as a fraction. It does need to be reduced. So if you will use on your calculator, instead of the division key, we're going to say do not divide. Instead of using your division key, you should have a fraction key. Most of them look like this. I believe Casio looks like this. If you will use that here instead of the division key, it will spit out an answer in fraction form. So try to leave your answers in fraction form. All right, let's look at another one. These are just going to get longer and longer. And what I'm going to do is I'm going to simplify this 3 plus 4. Keep this negative with my 11. 3 plus 4 is 7. And then I'm going to just rewrite the problem. I'm not touching anything but the 3 and 4. Now I'm going to get all of my x's on the left side, and I'm going to get all my whole numbers on the right side. I'm going to do this in one step. I'm going to move this 2x here. Now, if there's no sign in front of it, right here, there's no sign. It is understood to be plus, okay? It's understood to be a plus. So I'm going to move my plus 2x over that direction. I'm also going to move my 7 over, and remember, understood plus. I'm not touching my negative 11x. I am moving my plus 2x over. When I move a plus 2x, it becomes negative. I'm not touching my negative 1. I'm going to move my plus 7 over. When I move it, it becomes minus. Now I have all my x's on one side, all my numbers on the other side, and now I just start simplifying. Negative 11 minus 2 is negative 13x. Negative 1 minus 7 is negative 8. Now I'm going to move my negative 13 over here. Now, I have said this, I don't know how many times. The operation changes. The sign does not. So, what operation is happening here? Right here, no sign means multiply. So when I move this over, it's going to become division. The sign of the 13 is negative. The operation is multiplication. So the operation changes, the sign does not. So this becomes negative 8 divided by negative 13. And remember, I'm not going to use a division sign. I mean, at the division button, I'm going to use my fraction button to do 18, or negative 8, I'm sorry, fraction key, negative 13. Well, mine says error, but negative divided by a negative is a positive. 8 over 13. And you're going to just keep it as 8 over 13. Do not convert it to a decimal, okay? All right, let's look at this one. Now I put this one in here because of this right here. There's no number, it's called a coefficient. There's no coefficient in front of this x. But I have 1x. You have this thing in mathematics called understood 1. If you have a variable with no coefficient, with no number, there's an understood 1 there. All right, so I'm going to move my plus 1x over here. I am going to move my plus 3x over here. 17x is not moving. Plus understood 1x becomes minus 1x. And I write my 1's in there because they're really easy to forget. I'm not touching my equals. I'm not touching my 19. My plus 3 is going to move over and become minus 3. Now I'm going to simplify. 17x minus 1x is 16x. 19 minus 3 is 16. I'm going to move my 16 over. When I move it over, it becomes division because two things side by side means multiply. 16, I'm going to just write it as a fraction instead of writing it with a division sign. And what is anything over itself? 1. It is absolutely possible to have a 1 or a 0. I always have that question. My kids say, oh, I got a 0. It's obviously wrong. Well, I got a 1. It's okay. You can have a 0 or a 1 for an answer. So here are the steps, okay? Add any like terms. Move all variable terms to one side. That means if it has an x, move it to one side. I almost always move mine to the left. Then we're going to move all non-variable terms, and that should probably have a hyphen right there, to the other side. So anything without an x, move to the other side. Step 4, add any like terms that you have. And then step 5, multiply or divide as needed. You hardly ever multiply, but you almost always divide as your last step. Two things. Number 1, remember any understood 1's. Number 2, leave your fractions as answers. Nope, leave your answers as fractions. Okay, last, real quick. We're going to start, like I told you in our face-to-face time, doing your homework online so that I cannot drown in your homework, and then you guys can see your answers almost immediately. I think you can see when you get them right or wrong. If not, I'll try to figure out a way. I've paid for the subscription for that test thing that I'm using. Remember, it's not a test. I think it says Easy Test Maker, but these homework links are not tests. They're just homework. So don't forget to click the link that's on either the portal or the GroupMe app that you're using, and you can do your homework.